Right. So the thing about security and code quality, and I mean, you obviously came here for me to teach you about all that, right? None of you know anything about that. And I'm gonna do it. In an hour, I'm gonna teach you everything. Actually, yeah, yeah, you guys seem confused. Fine, we'll talk about the bison. Then I'll teach you everything about security and code quality and everything you need to know to succeed in this industry. Okay, so Avatar, The Last Airbender, I hope some of you watched it. I grew up on it. So the reason this is the first slide is because I had a talk with one of my friends about it. I told him, yeah, man, you gotta rewatch it. I grew up on that stuff. We all did, but also, I mean, it has a lot to teach you today. And he said, what? What am I gonna learn about from 12-year-olds running around bending the elements, like shooting firebolts? And I said, hey, hold on a second. I mean, yeah, I mean, it's a silly show. It's kind of, it is for kids. I mean, I'm not denying that, but I think that having knowledge about things is not enough for us to actually act upon this knowledge, right? So I think we all know, I mean, if I woke you in the middle of the night, asked you, hey, is friendship important? What about honor? What about humility? Most of you would say, yeah, let me fucking sleep. Sorry, let me sleep. Just came out of me, I'm sorry. Is there censorship in this conference? All right. Okay, so, but it doesn't necessarily mean that we act by those values. I think there's always a gap, and we'll talk about it a bit more later. So the thing is, the reason I'm bringing this up is I think that a lot of what I'm gonna say here, I mean, I hope it's not gonna be trivial. I hope it's not gonna be something that you guys find boring and isn't new to you at all. But I think most knowledge is kind of a remix of previous knowledge. So what I'm saying here is that we're gonna touch on kind of big, deep subjects. Some of them seem unrelated to the topic at hand, which I'll review again in a second. But I really want you to try to re-examine those concepts that you've known for a while. That's what I try to do, at least, and I always have to. So the point today is the synthesis of many subjects. They have to do with professional life, social life, all those things that construct our systems that we encounter day to day. And the thing is that those basic things are really crucial to our rational behavior in the day-to-day. So, an anecdote, I mean, sort of a small question I like to begin with is, if I show you these icons here, which do you find more consistently relevant? If you think the left side, raise your hand. All right, right side? Of course. And the thing is that tools often have way shorter lifespans than theoretical concepts. So, I mean, there's no issue with learning React or I don't know, a tool, those tools. But I think if we don't work on our basic concepts, I think I made this point already in the past 5 minutes, enough, is that we can't really construct anything, we can't really work with anything. So keep those things in mind. I really want all this to follow us during this lecture. And let's move on to the main subject. So obviously I don't know so much about security actually, because I'm a developer. I mean, we've been developing security products at Cisco, but a lot of you guys know way more about me than this. But the reason that I'm talking about code quality and how it relates to security, and by the way, I'm saying code quality because I feel like talking about clean code and stuff like that is too specific. So code quality, okay, I think that's intuitively makes sense. So I got really pissed off. And actually, if this wasn't a security conference, I wouldn't talk about security. Maybe it would have been like a small part of it, right? Because I got really pissed off by how much we keep talking about how we know how to engineer systems, but and me as well, by the way. And we rarely act upon it. We can read 15 books a year about clean code and architecture and best practices, and we rarely act upon it. One of the places, I'm not going to mention any specific places that I worked at, but they really, you'd ask them, is security important? Of course. What are we doing for it? Well, we're doing this and that. Can we examine maybe what we can do more, and maybe how things like how we write our code impact our security? And they would say, yeah, but we have no time for that, right? We'll do things the way we know because it's hard to break existing patterns. So I got really pissed off. I decided to do this talk. And since we're at a security conference, I'm going to focus on the security aspect of it. But honestly, what I want to talk about in general is how every part of the system that we work in is interrelated. Everything we do in some way or another impacts the whole system and other elements inside it. So why is this hard? I think this is kind of a hard problem to tackle. For several reasons, we won't cover them all, but 3 of those that kind of come to mind. So code quality is a very divisive subject. Everybody has their own opinions on what you should do to write good code. Everyone has their own opinions on what you should, even if you know that some things are good, maybe they're not worth your time. Maybe they have these effects and those effects, and this is not very important. And maybe when you're a startup, you don't care about that, and you care about this. So it's a really large subject. And obviously, I'm not unbiased. No one is. So I'm going to give you my view. And I encourage you to ask your own questions about this later. Second is, this is something not necessarily related to our topic. Finding real patterns in the world and what causes and correlations exists around us, and distinguishing between those correlations and causes is something that we try to do every day, and we often fail. That's part of what we are. So just to emphasize this point, so we have correlations and causations. To make this clear, think about research that was done a few years ago that actually saw that big weddings often are correlated with lasting and long-lasting relationships and marriages. Well, maybe then you should spend a lot of money on a wedding, right? That's the solution. So it turns out that this is not a causal relationship. The thing is that when you have a big wedding, it often points to a lot of financial resources. It points to a really big family and friend circle. And this leads to a happy, lasting relationship, not the wedding itself. So this is a correlational relationship. And to further emphasize this point, I hope none of you think that the fact that if we look in the 300 last years, we saw a very drastic increase in greenhouse gases, but a real decrease in Caribbean piracy. So I hope none of you think that we should bring back pirates in order to solve global warming. So that's a correlation, okay? It might seem trivial, but I think that we really make those connections on a day-to-day basis. This is actually something that we struggle to do, to find the real causes and patterns in the environment and in the world. So we're looking for causes here. And this is not easy. I'm not claiming to have mapped out all the causes and all the right patterns within this subject, but I'm doing my best with what we have. Third thing is that this is a multi-layered subject. So I'm gonna actually touch on the specific topic of code quality and how it leads to security after we clear up some topics beforehand. We have to kind of dive in to things that are related, that cause code to be good, and how human communication works. And you'll see what we'll tackle, but I really wanna dive into this. And in the last 10 minutes or so, or 15 minutes, we'll dive into the main point, right? So with that, Code quality, okay. So again, not everyone uses this term. They usually say clean code, best practices. But code quality is kind of larger than that. We're not going to talk about everything that composes this thing. But let's like get a general idea. So let's look at some best practices which are part of code quality. And I think we can all agree that these are some of them, right? Obviously not all of them. Marked with orange is tightly related, I think we can agree, to human communication. I think that not repeating yourself is not because the computer is going to get mad at you that you've written the same piece of code 15 times. Documentation, definitely, no computers don't read that. Actually, they started recently. I mean, most of that actually is about how we read our code and how other people read our code. So that's kind of a thing to think about, because I don't think the discussion about the fact that when code rests, it actually does nothing. It doesn't matter how it's written, right? When the repo you're working on is unobserved, it doesn't matter how it's written. It's just a bunch of ones and zeros, right? So we do all that just to understand ourselves and each other. So good engineers regularly discover their strengths and weaknesses as human beings. You communicate with yourself first and then with others about where you're at, what you should do, where you should go from here. And if you can, and which is really hard, if you can actually criticize yourself and give yourself, be like a nice, soft critic with yourself, accepting that you failed and that there's nothing wrong with that. And this type of communication really boosts your ability to actually improve in the future. So that's why I really want to cover communication with ourselves and with others before we actually talk about more technical aspects of this. So we use Python and JavaScript, and well, all of those are high-level languages. Java and C are too, but we prefer those, especially recently. I think actually I'm a Java fan, but I think most people prefer Python recently because they make sense to us better because they're easy to communicate. I mean, they're not very tight. Obviously, Python is almost every time when you run a Python program, it's gonna be slower than a Java program, but we prefer it still because, again, communication is so important to us, right? I mean, there's no other reason really, I think, that this thing got so big in the last 10 years. And I think this fact, that's what it can be treated like. I mean, we really value this aspect. But it's funny because we do value it. We do value not causing chaos in our systems. But again, we don't directly talk about it. You don't go around your office and saying, look, I mean, the reason I want you to write good code is because I want to understand you. And I want you to understand yourself in an hour. We just kind of lash out at each other sometimes, and we can't really always explain why, but there are reasons. And of course, forget code. We rely on communication way before we implement anything, right? When we start a company, we have to communicate with people. We have to make sure that people want to cooperate. This isn't something that, and again, we do this, but how many times do we spend actually improving those communication patterns and understanding them in their basics and examining how we actually act upon them in real life? And the thing is, it's really important because we know that today and in the past, our true potential is realized in collaboration. I mean, we can't really do much on our own. I think this is a lesson I learned when I started in this industry. I wanted to be a game developer before I was first a developer. And the thought was there was some kind of frame in my mind in which I'm just developing God of War on my own. Obviously, that's impossible. You really have to collaborate with people to transfer your ideas, and not only your technical ideas. In order, like when you want to make something for a game, like when you make a game, for example, you have to kind of communicate feelings, why you want this thing to work, why this is important to you. Obviously, this is not. You don't always have to convince people of that when you're building like a bank. You're not really talking about emotions usually, but still, it's crucial to our communication, both the technical things, the technicalities floating in our heads, and the emotions behind them are really nothing to gloss over. And we've always been like this. I mean, that's at least my opinion, and that's fine if it's not yours, but our species kind of rose to its current position because of this ability of ours. This is really central to our humanity, and we should really leverage that. Nothing amazing we created didn't have to do with communication. And supposedly we know this, but I don't always know it. I don't remember it when I'm trotting around the office thinking about my own things. Because if I would, I'd say good morning to everyone at the office, which I often fail to do. Now, in the same way that I fail to say good morning, miscommunication is the fuel of failure. When we fail to actually bring to others around us what we're actually thinking and seeing about this vision of ours that we're creating, it can really blow the whole thing apart. I mean, so many mistakes are because we didn't use the right words, we didn't say the right thing at the right time, because we were too tired to communicate properly because we thought about something else. And this is really emphasized in a study from 2003 by Baron, can't recall the last name, but it starts with B, when smart groups fail, from the Journal of the Learning Sciences. So it examined groups of 3 to 4 students, diverse backgrounds, which kind of broadens our data. They were given tasks that necessitated communication, and some patterns of behavior were correlated with success. So I think we should really take this into account when we build a new team. Maybe some of the insights from here. So first thing that was associated is active listening and constructive dialogue. So I meditate most days, I try to at least. And if anyone has ever told you that you should meditate because it should calm you down, that's not why we do that. It doesn't calm you down. It takes a lot of effort. Because the minute you close your eyes, you notice how much is going on inside your head. What we're really doing, at least in my opinion, is we're trying to train our attention. And attention is one of the most basic resources we have in life. I mean, I think a testament to that is when you go outside, especially in other countries. Norway is actually pretty light on that, but when you go to Manhattan and you have everything trying to get your attention, this thing is such an important resource. And the reason I'm bringing this up is because it's not that easy. You don't control your attention directly. You try to, but we control our attention by actually examining an object, by noticing its details. And obviously, in different states in ourselves and in our days, it can take more or less effort. Now, I'm bringing this up because active listening is really something you have to train. It won't happen by just thinking about it hard. In order to actively listen, you have to understand how to try to direct your attention to what people are saying. I do it for a few years and I still struggle with it every day. And the thing is, when you do active listening and you actually manage to actively understand what's happening, and when you comment on what people are saying to you, but not aggressively, not trying to grab the conversation to yourself, you actually engage and re-engage with who's speaking to you, and you can understand them deeply and also convey the fact that you're listening. Now, this creates a very strong connection. I mean, if you ever try this in a project, for example, if you're like, I know, maybe an application security specialist and you're talking to a developer, when you actually listen, it could create such a strong connection that would speed up the processes. And obviously, in my opinion, bring this to your home. This is even more important. Conflict management is also something that we shouldn't take lightly. Conflicts happen all the time. Not all of them are catastrophic. Not all of them present themselves that obviously. But a lot of our motivations are within ourselves and with others come in conflict. And resolving that has a lot of aspects to it. For one, you actually have to understand that the conflict happened. The diagnosis of the conflict is something that doesn't always happen. We often just say, no, I need this and this should happen and you have to agree with it. And then we kind of say, oh yeah, he agrees with it because it made so much sense. But we should first acknowledge the conflict and that we have, and try, and before even solving it, just understand that we have a problem on our hands, something we often skip. Once we do that, once we diagnose the conflict, we can actually dive into the details of it and see how we can, maybe we can work out some sort of compromise. Well, I don't have to explain conflicts to you. I'm sure you've been in a lot of them. Shared understanding. Now that's a central one. Shared understanding isn't something that's easy to achieve because when I am standing here talking to you, I have a completely different view. Like I'm blinded by this light that you guys can't see. The perspective from my view is so much different than yours. And when I actually talk, it originates with my thoughts. So obviously, what I'm saying meets you somewhere else. The words I'm saying are interpreted in a different way. So gaining shared understanding is also, first of all, complete understanding is impossible. We can't do it. We can't do it unless we invent some kind of neurological connection. But in order to gain shared understanding, we have to really emphasize a few things that we'll talk about later. Among them is language, the importance of the specific words we use. I promise this has to do with code quality and security, you'll see. Managing cognitive load. Now this one, it's intuitively understandable, I think. But anyway, from another talk I have a small illustration here. So basically, cognitive load, sorry, is something like this. So you have intrinsic load, which is data, information that is relevant to the task at hand that you're trying to accomplish. And then you have extraneous load, which is not, it doesn't contribute to the task at hand. For example, the fact that I chose black font over this pretty dark background is extraneous load. This is the information that doesn't contribute at all. Now, to further illustrate this, we have here Lucy. She's trying to learn about the history, I'm inventing this on the go, of Norway. Why not? And she has her working memory and information is flowing in. And when she's sitting by herself, she just had a great night's rest. She drank one coffee, not too much. She's not like jittery from coffee. And she's ingesting a lot of relevant information, no noise at all. She's like in perfect top condition. And then Alex comes and he starts blabbering about all sorts of subjects that he likes to talk about, and he can't stop himself. He just can't. And then some of this load becomes extraneous load. And I mean, we often try to do this anyway. I mean, I remember like, no, you're going to work through this. You're going to be someone who can study and dive into things and work within a tornado. And yeah, we can work on that, but we have to work on that. But in the meantime, value a quiet environment. And obviously, offices differ, and sometimes maybe some of you are bummed out because they put you in open space. Maybe some of you are bummed out because they didn't. But I mean, if you can construct a good environment, then do it. Anyway, so yeah, cognitive load really matters to get back to the topic at hand, because I wanted to illustrate this within within how groups fail is really important, because when you load too much cognitive load on the group or an individual from the group, when you try to process tasks that can't be processed that easily, it will really hurt your success. Now, the last thing is, I think, I wanna point this out particularly. I think this is like one of the things that is often misunderstood and that I have to really work to convince. I was talking with a colleague a few months ago, and he was explaining something about the code to me when we were, I think, in a meeting and we didn't have our computers. And he said, like, yeah, so I was working on this endpoint. It was if any of you know, it's a Python Django endpoint. And he said, like, yeah, so I put in the headers this piece of information. I was like, in the headers? Can you explain this to me a bit further? I couldn't accept this because it didn't make sense. And then he said, yeah, you know, the headers, when you enter the class and you have those variables. And he said, are you talking about the properties of the class? Now, I mean, and he said, yeah, but it's only the word I'm using. Oh yeah, it's only the word you're using. Oh, great, because I'm not using your words to understand you. I mean, sorry, I'm kind of pissed at him because of this, but he's a nice guy, I swear. He knows what he meant. He knows what he meant, and it makes sense to him. And he has this whole mental model of the thing, and that's fine. And he's an intelligent and smart guy. But he really has to use the right words if he wants us to share an understanding. I think this is often really misunderstood. We belittle the use of words and the weight of words. Now, well, basically, this one just says what I said. So words are tools to convey meaning. And some of them are crafted, I mean, from the get-go, with that purpose in mind, right? We'll look at it a bit more later. Thing is that we often, some words really don't work for us. I mean, we often overload them with meaning. We misuse them, just like we talked about right now. So why do they matter? Okay, I want to dive a bit more into this. So as I mentioned before, when we ingest language, a mental picture is invoked. We're constructing an inner world of symbols and images and colors and sounds and emotions when we hear words. And these models, I would argue, are key to collaboration. I mean, have you ever noticed, if you worked in mostly in larger groups, but it also happens in smaller ones, that services tend to separate into parts that kind of correspond to the teams, also the sizes of the teams. We don't have to do this. I mean, if you would remove the context, I think, and ideally the services and separation wouldn't look the same at all. But we tend to do this because this is the way that our relationships work. I mean, I have no evidence to back this up, but this is an argument that I would like to make. So what does it look like when we fail to do that? What does it look like when we can't really maintain a consistent model and everybody has a completely different image of the system? This guy only has a part of it, and this guy kind of invented the service, and this guy kind of looks at the service but didn't understand the point at all, which, I mean, it makes sense. So the way it works is we have a few ways that we kind of make words of less quality, right? So what I mean is that an example of this is when we overload a word. I personally think, and this is kind of, I like philosophizing, so you'll have to forgive me for that, but I think love is kind of it doesn't serve us right, the way we use this word. Because I say I love my mom, and like, oh, you love your mom, that's amazing, but I also say I love avocado. And I mean completely different things by that. Actually, the ancient Greeks had 3 words for love. They had philia, eros, and agape to illustrate what they meant. Each one has sort of a different color to it. When you say philia, it's kind of a friendship love. When you're on the same level, when you're collaborating, and eros is more about relationships and all that. and agape is more of the love that you have for your child. And I think that really it's way stronger because we use love for like 600 different things. So, I mean, I talk about love because, again, I love philosophizing, but also we can see that in stuff like when we try to talk about front end. I mean, it doesn't happen all the time, but when we use, like when we say the word interface and we're writing in TypeScript, you really have to provide context, because are you talking about the interface like within TypeScript, you know, the interface that allows you to inherit from, or are you talking about the user interface? And you would be amazed how many conversations like this actually get derailed completely because of this misuse and misclarification. So we can't always solve this problem, but we should be aware of it, and that it's important to provide context if we want to be heard. Second thing is foreignness. Actually, I mean, I won't dive into this, but you can. There's a really good series of talks that I recommend by Professor John Vervaeke from the University of Toronto, and he talks about that almost every word, I mean, most words in our language are metaphors. Okay, even the word metaphor is in itself a metaphor. He explains it way better than me, but thing is, we always connect something to previous constructs in our heads. So, for example, I think if any of you ever used reactive or functional programming, we have this concept of monads, which I've never heard this word before. I used it in functional programming. It's basically, I wrote it down here, it's a design pattern used to handle program-wide concerns like state or IO, whatever. But the thing is, it's a word that I've never heard before, and it doesn't, I mean, it has its freshness to it, which is kind of a merit to its own. But if I want someone to understand what it means, I want to make it learnable and ingestible, then I should use a more familiar word. For example, when you first learn programming and you hear the word loop, it's easy to understand because it has so much else to do. Like, yeah, I played Sonic the Hedgehog, I know what loops are. Third is complexity. Now that's a problem that I tend to cause. I complexify things. I often I have this tendency to get into subjects, and you probably felt it already, but I tend to complexify things that don't always have to be complex. I mean, you can complicate everything if you want. And when we do that, we put a lot of stress. It kind of causes cognitive load. You have to hold a lot in your head. You have to kind of make a synthesis of things, and maybe some of them don't make sense to you, and so maybe some of them are complex on their own, and I expect you to know them already. So language can often become that, which, for example, when we use a high or formal language, it's usually more complex and foreign to us also, from the point before. Fourth is simplicity. Now, I mean, it directly conflicts with what I just said. I mean, yeah, you gotta be simple all the time, right, to avoid complexity, but not necessarily. Some things should be complex because we're trying to understand them very deeply, because this is what we're doing, because this is our responsibility. And some things should be very simple, right? But not always. Not always. Some people, I think, like most people, have a tendency to either that or this. Some people try to simplify everything, which I don't get that at all because I'm not like this at all. But some people try to complexify everything, complicate everything. We should try to find a balance. We'll never make it. We'll never actually find the perfect balance, but we should strive for that. Now, to move on, and again, we're almost getting there. In order to actually construct strong, resilient systems of behavior and communication, we really need teaching the distribution of knowledge. And of course, mentorship and all that, we'll talk about that in a second. But thing is that we're going to see how code actually holds its communication for us soon. Now, thing is, even good code review can't cover everything, right? Even if you have someone who's very much on it and leaves, like it happened to me a few months ago when I had, like, on a pull request in an open source project, like 120 comments. I think it was a nightmare. But even that didn't catch everything because we're biased, because we're blind. We're blind to things that we're not used to see. So we really have to teach effectively, which is really not an easy task. I mean, I used to be a teacher for a full stack course, and I found out very soon that I had so many basic skills that I was missing. For example, active listening. For example, managing my energy. I was overstressed back then. So we have conditions that we should be under when we want to learn and teach effectively. First of all, humans don't really understand things when they hear them only once. I don't think that's how we work. I think there's a really good Alain de Botton has some lectures in which he talks about this, that in order to actually understand, for example, something that the church did way better than university is that it repeats its points. It tells you what you should do and why every morning, and this is actually the only way that we behaviorally learn. But in your degree or in school, you're told a very complex new subject, and then they expect you to puke it out in a test a few weeks later, as if that's enough to ingest. But obviously, it's not. Second is clear information. Well, something interesting is that we have a tendency to find information, and again, I'll refer you to John Vervaeke for this. Find information that's more clear and easily digestible, more accessible to us. For example, black on white fonts, more trustworthy than information that isn't. This is something that was studied a lot. So, no, I mean, we also, apart from it being understandable to us, we also trust it more. We also remember it more. We also care about it more. We have an emotional reaction to it. Third is steady progression. We shouldn't try to jump to levels that we're not at yet. I tried, I think, after a year of experience, to develop a game engine with C++, which I was barely familiar with. In order to actually achieve that, I needed, I'd say, considerable experience with C++, which I hadn't. I think it's called SDL, which is a game frame, a graphics framework. Some experience with OpenGL. So when you try to learn things that you just don't know the basics of, it fails. And the fourth is we really need feedback. We need to know how we're doing, because when we don't know where to correct. We can really, when I was little, I had this thing that I only picked the guitar from the top. Like I could only down pick. It makes sense to you. I don't know if you don't play guitar, it might be weird what I'm saying, but when you play guitar, you have to alternatively pick from the top and the bottom. And honestly, it would be better to not learn this bad habit before. So I learned by myself, so I didn't have the feedback to stop doing that. So I just kept on strengthening a connection within my brain that wasn't good for my progression. And something like the correct environment, as we touched on before. Now, the reason I'm talking about effective learning, you'll see, again, I'll emphasize this, that we're getting there in a second. Code quality does the teaching for us when the repo is actually good. But of course, the mentor is also responsible. You have to have patience as a mentor. You have to understand your students in a very deep and intimate way. You have to know when to help and when to introduce challenges. You have to know how to provide feedback like we just talked about, and on and on. Now, again, high quality code bases do the teaching for you. And that's also to do with security, because obviously we have things like input validation and all that. When we have code bases that are clear, that have regular reusable types, we tend to use them, and we'll see that later in further depth. But I really want to talk about in what general ways it helps us learn. So when you have a new engineer, for example, and he tries to understand what the code base looks like, it's much easier if it's modular, if it has layers to it that he can understand separately, and then say, okay, I get this layer, now to the next one. Modularity is very digestible. And this way, again, where I'm going with this is that it can help you also do more secure practices. Good naming clears up confusion. When names are concise, when they actually do what they're supposed to, and this is not an easy task, as you all found out, I bet. It's just way easier for us to understand intuitively and quickly what we're seeing. Encapsulation reduces cognitive load, right? So you have, when you, for example, develop an API, you don't want your SQL queries, for example, to be in the same layer, because then you have to process way too more in order to understand the layer you're dealing with. But you don't want to do anything with the repository or the data layer at this point. So when you encapsulate the layer and also separate it, which we'll see is also a good practice, you allow who's ever reading or writing it to just deal with what they have to. And in general, when you use design patterns that were tested, that have their own points and have their own history, you can really reduce complexity, because you can move the attention of whoever is dealing with it to what the functionality of this thing does, right? We don't do design patterns for the computer. It really doesn't need any factories. It doesn't need any strategy patterns in order to work. We do it in order to manage it better, to write less, do more. And last thing is something I insist on everywhere I go, is constraints. Mostly types. If I use Python, for example, I always try to convince my team to add type checks that force typing within the CI/CD. And things like access modifiers, which you can find in languages like Golang and Java. Well, I think it's intuitively understandable why they help. So basically, as I said before, when a code base is unobserved, it simply runs as is. We don't really care about what code is written like when it's not observed. Thing is, I mean, it's really important, but code isn't the whole system, right? Most of the system isn't code, actually. Most of what we deal with is other constructs. But as I said before, I would argue that code reflects and well, it definitely impacts the system, because in many ways it allows the system to function, but it also impacts it very, very deeply, because, and we'll see soon, that systems have their own elements and they all have relationships to each other, and the impact spreads, and it's actually pretty difficult to trace. We'll see it soon. So in order to understand it better, what exactly is a system? So that's what Wikipedia says. It's a group of interacting or interrelated elements that act according to a set of rules to form a unified whole. So an illustration. You have a bunch of elements. Arrows are a relationship to one side, right? So this element affects this element, and the element at the bottom here affects the element at the top, but the element at the top also affects it. So some of them are go two ways. For example, in a system, the humans in the system and the finances in the system affect each other, right? The financial state really affects human resources. Then we add sales. Now, the sales definitely affects humans, right? I mean, they have to do this, the selling, for example, but also it affects how much income is within the system, which affects the finances. So basically, each of these connections form a new connection. Same with code. Humans affect code, but also, as we discussed, code affects humans. And also, thing is, I would say that this relationship goes something like this. So you have code that affects humans, that affects security, that affects code, right? I mean, we all know that you have to implement you have to do some social engineering, both to hack and to protect the system. You have to rely on people not leaking information. And also, you have to rely on people writing good code. I mean, those things affect each other. This is not only I mean, this is so complex that you can't even describe it that well, but I really hope that this comes across, right? Because when humans care about security, they both write secure code, but also they behave in secure ways. You know, you see where I'm going with this? This is not a simple relationship. This is a whole system of interrelated and intricate relationships. And of course, it also affects finance. I mean, first and foremost, I think within the world we live in today, you don't want security issues because you would lose money. So just an anecdote here. So basically, the point is that changes in an element affect the whole system. So, and again, the reason it might seem trivial to some of you, but really, from my experience from several places where I worked as an engineer, people ignore this fact. They don't always look at what's next after their actions. They write code, and not only the developers, right? Even managers, they don't try to invest in policies that improve their code quality, and they can't really easily trace how it affected their security, how it affected their finances, how it affected everything, how it affected the satisfactions of their employees, right? Because they're in an unprofessional place, for example. But the point is that in general, we can say that every element quality that increases the system quality, right? This is the point I'm trying to make here. And again, it might seem trivial, and it might be to some of you. It might be something you thought about a lot on the way here and at work. But the thing is, I don't think we think about this day to day. So everything we do has an impact. And we can't be aware of everything, but we know that we should invest when we can. Now let's get to security, okay? Let's dive a bit into this. I'm not gonna cover security here. Just to clarify, in the beginning it was a joke. So again, we won't dive into this concept. I just want to connect it to everything we talked about. So in general, when you try to understand what is security, you go with statements like, okay, so in order to be secure, not only in our industry, by the way, in general, you need less harm. So we invest in security, right? That's something that we want. But nothing is completely secure. I mean, we try to, for example, in one of the places I worked at, they really poured a lot of money on security, right? But that's the only approach they could take. So there was a lot more to do, but when you're used to solve problems one way, you won't necessarily do it in others. So that's what we're doing here. So even though nothing is completely secure, we can strive for it to be more. And we'll see in a second why I'm saying all this. So these are just a few, like we did in the beginning, security best practices that I want to point out. And I would argue, and you might agree, that everything marked in orange is enabled or simplified in high quality systems, right? So when you have, for example, separation of duties, it makes it much more easier to to adjust levels of security that are required, right? Because if you have everything in one place, then you would reduce or increase for the whole system. Or for example, auditing. If you have a system that's of high quality and you invested in observability, for example, then both debugging and security auditing and logging becomes way simpler, right? So the point I'm making is this. We have system quality. Code quality affects it directly. And we have finance management, etc. And then we have the level of security. Now they both affect the system quality. And remember, we just said that the system quality affects everything else. Thing is that I would argue, and I think we just saw now, that system quality also increases the level of security. So again, for example, good separation of concerns can enable better security audits. We can see it doesn't have to be monolith. I'm not arguing, by the way, that monoliths are not a good idea. I'm just saying that if there are concerns that you wouldn't want within a service, you should separate them somewhere else. Back to the relationships. So what we're seeing now is that code quality increases system quality, and system quality increases the level of security. But also I would say that code quality directly increases level of security. Now, why am I saying this? Let's look at an endpoint. And I would argue that this is a high quality endpoint, right? Because it has reusable middleware for data sanitization, right? You just use this middleware wherever you want to, and you can plug it in, so you don't necessarily have to worry about all that. Then a logic layer to simplify and control each layer better, right? You see the post service, this is basic MVC structure. You have schemas for input and output and increased clarity in auditing. So using those schemas really clear up what your inputs and outputs of the system are, of the endpoint are. And I mean, okay, good. So I know everyone knows how to do that. People develop APIs all the time. But what I'm really emphasizing here is not only the fact that these things work, but also how they work. So I hope you can see this right, but because this is a bit more text. But when this, we can see here that there's no schemas in the input and outputs. So for example, when a security audit occurs, you can't really easily tell just by looking at it how much, what data is being passed. Now imagine doing this for like 500 endpoints, right? The sanitization is manual, so you expect, so you either didn't educate your developers well enough, or you expect them to implement everything from the get-go every time. So what if, I mean, fine, this works. It's being HTML escaped. You're protected from cross-site scripting. But what if in the next implementation someone would forget to do this, right? This is very likely to happen. And you can see here that the SQL query is in line within the endpoint, which again, in order to actually understand what's going on here and what's being passed, I have to, well, you could argue that this is easier because it's in one place, but I'm saying, what if I'm looking only at the API right now? Why do I have to, when I'm auditing this thing for 1,000 endpoints, also look at this, which has nothing to do with what I'm actually trying to understand here? So some of these things that I just talked about directly affect security, like input sanitization and providing middleware and tools to do it effectively every time. But some of them do it just by being way more concise and making the system much more manageable. And I didn't even cover testing here, which is obviously very important, and so many other things. But I'm hoping that the point still comes across. So let's not forget that the quality of communication, I mean, we've argued that quality of communication and engineering discipline really affects code quality, which therefore affects the system quality and the level of security. And I would argue that it also affects directly the system quality in general, which is a point within itself. All right, so I hope that I actually managed to draw some connections that weren't necessarily there before. But either way, even if I have, does knowing all this help? Well, yes, if you agree with me, of course. But the thing is, I mean, first of all, yeah, it does help. It helps because, and allow me to quote a really good psychiatrist from YouTube that I really like, Dr. Alok Kanogia, which I hope I didn't butcher. 50% of his job, he says, is not treatment but diagnosis. So we go through life trying, or at least claiming, that we know what our problems are, and we just don't have solutions for them. But the thing is, I don't even think that we know what our problems are. I mean, what sparked this talk is that I tried to convince for over a year some people at work that we should really invest in the quality of our code, and that it impacts our security. And I've noticed some specific things that were unsecure because of this code quality issue. And I think that this issue was an issue of diagnosis, not of solution, not of actually finding a solution. We couldn't agree on the fact that this is the problem, right? But even if we diagnose, is it enough? Well, also I'd say probably not. And that's because we can learn 15 books a year about clean code, but it doesn't mean that we're coding in a way that's clean or effective. And again, I brought it up earlier. there was a nice and interesting research back in 2017 by Matthew and Tucker. Current understandings of the research practice gap in nursing. It was about nursing, but obviously it applies to everything in life. We have a gap between what we know and what we do and what our habits are. It's knowing something doesn't translate to action. It doesn't. That's why I made this talk, because I think that, you know, like I told my friend, and I presented it in the beginning of the talk. Yeah, we know that friendship is important. We know things like, I mean, it's amazing. Avatar brought to the forefront things like feminism in like 2004 to kids, which is amazing. We know those things are important today, but we don't necessarily transform ourselves and our lives to actually live by this. So what I'm saying isn't enough, but I hope it's a start of diagnosing what we have to do. And what can we do? Well, regularly reflect. I recommend meditation and mindfulness. Choose our words with care. Give weight to them because they do matter, I would argue. Educate ourselves. Actually learn about things. We can't say that things are important if we spend zero time on them. We can't. This is hypocrisy, I would say. And I get it, by the way. I'm not judging anyone. I do it all the time too. But let's try, right? Embrace failure. Failure is part of the plan. That's what life is like. Failure is meant to happen. If you ever play Dark Souls, you'd know that. Be willing to change. You're not perfect, you shouldn't be, and changing is inevitable. You either change to one direction or to the other. So be willing to change to things and to places that are right for you. And we're almost at the end. Just want to cover real quick, what did we learn here? At least I hope. So first, why code is actually a form of communication. We talked about the fact that we use high-level languages to communicate with ourselves in the future and other people that are around us. How language shapes our mental models. I think this is a very crucial point, and I hope I can make it across effectively. How code reflects our mental models. I mean, this is a transfer from the first point to this one, right? So we have our mental models, code reflects them, I would argue. And we can see that. We can see that in a lot of companies and systems. How a system and its elements relate. Which again, you might have been aware of that, but again, the language we use to describe it is something that I wanted to bring across. And what the relationship between code and security looks like within a system. That's the main point here, right? I'm trying to draw the relationship between them. Hope it came across. And why we might fail to act out our knowledge. Again, I recommend meditation and stuff like that. They really help you manage the chaotic nature of your life. And with that, thank you for being here with me. I know I've taxed your attention and time, but thank you, and enjoy the rest of the conference.